Our next presenter is Richard Lanier, who has over 39 years of experience in the railway industry and provides senior technical guidance related to railway engineering and operational matters. He has successfully managed large multidiscipline railway projects involving planning, design, material procurement, material distribution, construction, and project management. Richard is a career railroader who has held senior technical and managerial positions for 2 North American Class 1 railways, and most recently was Stantec's rail sector lead, responsible for business and resource development and senior technical advisory services. Join me in welcoming Richard.
Thanks, Kevin. Just let me know if you can see that.
Yep, looks good.
Are you seeing the full screen?
We're seeing the presenter view.
There we go.
There you go, yeah.
Okay, thanks a lot. And thanks for this opportunity to present. And here, my topic today is the development of railway terminals within the context of precision schedule railroading principles in here, or PSR. The supply chain, as many people know in here, is a fragile system, and it's relying on the multiple modes of transportation, and disruptions and delays in any link can and will disrupt the entire chain. So PSR, why does this matter? Well, rail transportation supports domestic and international supply chains driving the Canadian economy. Local disruptions in rail traffic translates into extensive delays over thousands of kilometers, congesting rail lines, yards, and terminals. Delays translate into higher demands for resources, that being rail cars, locomotives, train crews, and a whole bunch of other things, driving up costs and causing more congestion. So recovery from short-term delays locally requires extended timeframes to reestablish the network. PSR, what is it? Well, at a high level, it's a set of principles that guide railway business and operating practices. The goal is excellence in rail service through safe, efficient, predictable, and reliable operations and service. Reliability relies on seamless interface between rail yard operations and mainline operations. So industry plants, which is basically what I'm talking about for terminals, is industry terminal designs and operations need to also be developed and through the lens of PSR. PSR, why is it important? Well, again, recent disruptions we've seen in our railway service highlight the importance a rail service has on the supply chains and the health of our economy and well-being of the nation. So PSR benefits translate into a competitive advantage for everybody globally, domestic, with global and domestic markets, lower costs for goods and opportunities for sustainable growth. So PSR benefits everyone, producers and consumers, not just the railways. So from a railway perspective, the objectives are safe, cost-effective, efficient, and timely service. So how does it work? Well, controlling costs, maximizing asset utilization, highly precise operating plans, and most importantly, synergy across all processes. Optimizing the rail network is important from a comprehensive end-to-end perspective in here, much different perspective than before. Focus on the carload, not the train. Scheduling trains which run on time is key, obviously, to meet customer commitments, and that's really what it's all about today. Optimizing every process affecting on-time delivery is key. As railroaders know, you plan, you execute, you monitor, you analyze, and then you rejig the plan and do it again and just keep improving. PSR has a number of guiding principles in here overall, and number one being safety, timely service, cost control, asset utilization, and people as being the binder and the basis for all other principles. To complement this, there are service design principles. And here, the service, it's a balance of all principles in here, because too much focus in any one area will obviously have a negative impact on others, and then that disrupts everything. So starting with car utilization and optimization. So if you can reduce the number of cars, you can have a positive impact on dwell in the terminals. You can reduce your car cycles. You can reduce the amount of space you need in the terminals. You can reduce the amount of effort in switching and overall reduce your costs. Now, focusing on fuel, power, train builds. Okay, overpowering a train in here, it just is more of a waste of resources. The productive speed doesn't really counter what the negative impacts are. So today, the focus is on longer trains. If we can create longer trains in here, we can certainly look at reducing the number of train starts, which has a positive impact on the resources, locomotives, crews, fuel, and a positive impact on reducing congestion and obviously reducing costs. Now, there's two types of services, and I'm talking about manifest and unit train service, and I'm including intermodal as a type of unit train in here. So PSR promotes a mixed balance of traffic in here with the idea of reducing train starts, again, reducing the requirements for resources and having positive impacts on congestion and costs again. Now let's talk about unit trains for a second. To be efficient in here, you need to have certain things that fall into place. You need to really be focusing on 7-day per week operation. Usually there are 100 plus cars in a train and a single origin destination pair. The most important thing here is optimizing the service plan from a network performance perspective. Traditionally, you'd look at what was happening in my rail yard, what was happening on my corridor. Well, that's not the way you look at it today. It's really how are things flowing for the network. So how do you do that? Having multiple traffic outlets is key as far as improving the flexibility with the operation, reducing risks, and reducing the opportunity for congestion on the main lines. The other thing is balancing traffic in both directions. It improves the reliability of the operation. It has a positive effect on reducing dwell time in the terminals. And again, once again, reducing congestion and lowering costs. Okay, industry. Let's talk about it from a terminal perspective. The railway terminal is the interface between industry and railways in here. Everything starts with the products, the property of the products, and most importantly, the production rate. Usually you start with the annual amount of production that whatever you're trying to generate is generated, and you work it down to a daily production. Once you've done that, you can really start to plan for what kind of rail car do I need? What capacity do I need? The type of rail service, is it enough for unit trains? Is it a manifest service? What is the frequency of that service? The number of cars, the number of loading or unloading stations, the speed of loading or unloading, the number and length of railway tracks in your rail yard, the requirements for storage in your yards, and most importantly, having a daily terminal operating plan. So lots of things come off of that. So let's talk about the fleet for a second. The objective here, obviously, minimize the car fleet as best possible. You do that through using the largest GVW permitted and the largest carrying capacity in a car. The shortest car length, obviously, to try to keep the track lengths and capacity in the usable space to a minimum. Having an allowance for bad orders and maintenance, and certainly an allowance for transit delays. Location is really key as well. If you can avoid restricted weight and speed restricted lines in here, you can certainly have a positive impact on the number of cars, cycle time, the space requirements, the switching effort, and obviously the cost. So it's kind of key. Now that you've got a fleet, you need to manage it in here. So a lot of data systems out there in here. You can track utilization, that being this time and services, the distances being traveled, the percent of time cars are loaded and unloaded. You can track the health of your car and your fleet, and certainly track and monitor your equipment in here. So location is key. I'll come back to that in a minute. Measuring the load, measuring the brake status, the wheel and bearing performance, and door and hatch securement from a safety perspective are all kind of key things that you could put sensors on these cars and you can track. Amstead Digital Solutions has a telemetric platform that collects accurate real-time data which can generate actionable and predictive intelligence, can optimize the fleet, i.e. the number of cars and assets, improve safety, reduce costs while delivering the required level of service. Okay, let's talk about the terminal operations. I see it in three different types of processes. You've got your plant production, you've got your rail yard, then you got your rail service, and they've all got to work together. Disruptions like the supply chain and anyone will disrupt everything else. So storage is required to compensate for day-to-day variations in production and unplanned disruptions. So storage requirements is a risk assessment, and it's a detailed risk assessment. And generally, you try to quantify this in the number of days of production. So there's two types of storage that are key here. One is material storage. The other one is rail car storage. And having more storage than you need is certainly a waste of assets. But, on the insufficiency side, if you have insufficient storage capacity in your plant in here, you have a risk of shutting down your plant, but not a big risk in your terminal. But it's not the same situation in the rail yard, because if you don't have enough storage capacity in the rail yard, you risk to not just congest your plant, but also your terminal, and then disrupt your rail service. So PSR promotes 7-day-a-week operation. Assuming no other disruptions and things are operating the way they should, then there should be no additional demand for rail car storage. That's the ideal situation. So 7-day operation also promotes a reliable rail service due to consistent and predictable level of service, that being the demand for locomotives, train crews, a balance of traffic in two directions, and car dwell. Now, 5-day operations is not uncommon in here, but it creates an imbalance in car flows in here. So if you're working Monday to Fridays, hey, what happens on the weekends when your cars show up? And they're going to. Some days productions, you're not going to see anything return, and other days you're going to see more than you expect to return. So you got to be able to deal with these things. So 7-day operation provides that smooth, consistent service in here. It's not that you can't do it. A lot of services are provided that way, but it's not as efficient. And like unit trains, if you don't run them every day and you try to run them every other day, you've got to have additional capacity to store the extra production in here. Now you've got an imbalance in two-way traffic in here because you're running every other day and not every day. And now you've got an inconsistency in the demand for resources to run those trains. Okay, what kind of technologies do we have today in the rail yards in here? Well, we can certainly manage the moving car fleet in here. There's belt packs. People on the ground can control the trains remotely, or you can do it from a control center. Turnouts in the rail yard, you've got radio controls. You can do them from the ground, or you can do them from control centers. From a safety perspective in here, the Zone Guard is an electronic hazard protection system that protects workers from active rail-bound equipment, something that they wear on their body. LORAM has another piece of equipment that's an area monitoring, which automatically detects objects in the path of moving equipment. So you're protected both ways. So it's good to know that we've got that kind of safety equipment in the yards these days, because yards are the most hazardous place to work on the rail. Aei Car Tracking, these are electronic car readers in here. So they track the consist of trains entering and departing yards and terminals in here, but they can be used for real-time location of cars within the terminal and usually help improve the efficiency of knowing what you've got and where it is. Custody transfer systems are scales and meters in here. So two focuses here. One is the transactional one for accurate measurement of the substances that are being transported between parties. But from a regulatory perspective, you need to generate a train manifest prior to departure, which includes the identification of hazardous commodities. Okay, rail service. You know, every car has a trip plan from origin to destination. The types of disruptions you can sort of see in service could be mechanical repairs or missing connections due to the network congestion, slow orders on the main lines, track condition, bridge condition, or congestion in classification yards. So, you know, tracking cars is important. So you need to know where your cars, where do they get hung up? Why are they hung up? What is being done about it? And most importantly, you know, what is my recovery plan at the terminal back home so that I can plan for these things? You know, we're talking about complex supply chains in here, and you need better tools to manage the complexity these days. Some people will call it the digital railway. I like that term, multifaceted, end-to-end, seamless digital platform. We're talking real-time connectivity using state-of-the-art technologies. So transparency and alignment between the rail operators and the terminal operators is certainly key, especially when you can share real-time data. CN's got a track and trace API that allows effective transmission of real-time data to their customers in between computer systems. So you can, you know, look at GPS tracking and it'll generate reports on ETAs for interchange points, rail destinations, and customer sites. As an example, CanDo has created a tool called Quasar Technology. This sounds really interesting. Multi-purpose platform which utilizes leading edge IoT technology to create a digital twin of the customer's supply chain. That's incredible. It handles asset management, real-time rail car tracking, shipment management, yard and terminal management, transportation cost management. And again, with all the data it collects, it can perform metrics and predictive and prescriptive analytics. It's an incredible tool. So in conclusion, the reliability and efficiency of fluid railway networks rely on the seamless interface between industry and railroads. The benefits include fast and more reliable transportation service, lower costs, overall supply chain stability, competitive edges in the marketplaces, lower costs for goods, and opportunities for economic growth. PSR has taken the railway industry to a much higher standard of performance and a higher level of success. These concepts and principles continue to evolve and will continue to evolve. So the true potential PSR will be realized when the operating practices between competing railways, customers, ports, and other supply chain entities become standardized, generating closer collaboration and alliances, resulting in greater benefits for the customer at the end of the day, regardless of the routes or the carrier engaged. And the future success of PSR is dependent upon innovation, the ongoing development and implementation of new technologies through the evolution of the digital railway, while improving safety, reliability, efficiency, and utilization of assets while managing costs and delivering superior service. So I challenge the group around us here today, as far as we were talking about new opportunities for research and develop. Lots of them I just touched on. I've provided a number of links in the paper and here to some of the technologies I've talked about here today. I want to thank you for the opportunity of presenting, and we got a few minutes. Happy to answer any questions.
Hey, Richard, thanks for that great presentation. It was interesting to see kind of looking at the railway and kind of the BIM or the BIM model that's being used in building management systems as well. So it's kind of interesting to see that being transitioned over. We are running a little bit over, so we're going to jump right into the next presentation. So thanks so much.
Hey, you're welcome.